There's a specific kind of silence that just terrifies every IT professional.
Oh, I know this one.
It's not the quiet of an empty office. It's the silence of a dashboard that's all green, while your phone is just exploding with messages because nobody can log in.
Yes, the green light illusion. Everything looks perfectly fine on the surface, but the house is burning down inside.
Exactly. We spend so much time building the perfect infrastructure, the VMs, the VNets, all of it, and we sometimes treat monitoring like it's an afterthought.
It's like building a high-performance car and then just forgetting to put in the speedometer or the check engine light.
We are flipping that script today. We are doing a deep dive into Domain 5 of the AZ-104 exam, Monitor and Maintain Azure Resources.
Which, on paper, it's about 10 to 15% of the exam. But if you talk to anyone actually running this stuff in production, this is like 90% of their daily stress.
And probably 100% of their jobs here.
Absolutely.
Right. This is the keep your job domain. We've got a huge stack of material today. Microsoft loan paths, technical cheat sheets, some really good notes from admins who've learned these lessons the hard way.
And our mission is to get past just memorizing terms. It's about understanding two big ideas, observability and insurance.
I like that framing.
Observability is knowing what's happening right now so you aren't flying blind. And insurance.
Right.
Well, that's knowing you can recover when, not if, something goes sideways.
Okay, so let's start with observability, the pulse of the cloud. We have to be talking about Azure Monitor.
Azure Monitor is the beast. It really is this centralized hub. I mean, back in the on-prem days, you'd have one tool for network traffic, another for server health, another for your logs.
5 different browser tabs open at all times.
Exactly. Azure Monitor tries to bring all of that into a single pane of glass.
But single pane of glass is a bit of a marketing term, isn't it? Because when you open it, you're immediately hit with 2 very different kinds of data, metrics and logs. The sources are really clear about this distinction.
They are. And it's critical. Let's think of it like driving a car. Metrics are your dashboard gauges.
Speedometer, fuel level.
Exactly. They're numerical, time-based. CPU is at 80%. Disk queue length is 5. They tell you the current state.
So they're really lightweight.
Extremely. They're just numbers, so they don't take up much space. They're collected in real time. And here's a key point for the exam. And your budget host level metrics are generally free. You don't have to do anything to see your CPU spiking. It's just there.
Okay, so metrics tell me that something is happening. The car is vibrating, but they don't tell me why.
Perfect analogy. For the why, you need logs. Logs are the mechanic's full diagnostic report. They're text-based, they're heavy, they're complex. They say things like, Process X crashed with Air 500 because user Y deleted a fin file at 2:00 p.m.
And unlike those lightweight metrics, you can't just store these in thin air.
No, you need a container for them. In Azure, that's your log analytics workspace. Think of it as this massive searchable database for all your log data.
And that's where the cost comes in.
Right. You're paying for ingestion, how much data you pour in, and for retention, how long you keep it around.
And to search that database, you need to use that acronym that always comes up, KQL.
Custo Query Language.
Yeah.
It's a bit like SQL, but it's really optimized for these huge time series data sets. For AZ-104, you don't need to be a wizard, but you do need to recognize the syntax. It's very pipe heavy.
Like PowerShell.
Kind of, yeah. You'll see source where time one atch count. It flows.
Now, there's a trap here. The source material really highlights. I think a lot of people fall into it. You create a new key vault, and you just assume Azure is logging everything about it.
That silent failure we talked about at the start. It's a dangerous assumption. By default, Azure collects platform metrics. Is the service on? Is it running? But it does not collect detailed resource logs.
So if you want to know who accessed the secret, you're out of luck.
Unless you've explicitly turned on logging for it, and that is what's called diagnostic settings. You have to go into the resource itself, find the diagnostic settings blade, and tell Azure, hey, take these logs and send them somewhere.
And we've got 3 main somewheres, right? The destination is really important.
The big 3. First, as we said, the log analytics workspace. You send them there if you want to query them, build dashboards, and troubleshoot in real time. It's the most powerful option.
And the most expensive.
Second option is a storage account.
For archiving.
Yep. This is your cheap, long-term cold storage. You have a compliance rule that says you have to keep logs for 7 years. You dump them in a storage account. You're not going to query them, but they're there for the auditors.
And the third one is for getting data out of Azure.
Event hubs. That's a streaming service. You use that when you want to send your logs to a third-party tool like Splunk or Datadog, or maybe your own SIEM.
So the big takeaway is No diagnostic settings, no data. You can't troubleshoot what you didn't save.
That's it. And for the exam, just look for the keywords. Query means log analytics. Long-term retention, or cheapest, means storage account.
Great tip. Okay, so we're collecting all this data. But, I mean, nobody can stare at a dashboard 24/7. I need the system to tell me when something's on fire. We're talking
The
alerts.
tap on the shoulder, or, the punch in the face, depending on the severity.
The sources break down an alert into three core parts: signal, criteria, action.
It's a really logical flow.
Okay.
The signal is what we're watching. That could be a metric like CPU percentage, or even the result of a TQL query.
Okay. Then the criteria is the logic.
Right. When do we panic? Is the CPU greater than 90% for a continuous 5 minutes? That's your criteria.
And then finally the action. What happens next?
And in Azure, we handle this with something called action groups. And they're great because they stop you from repeating yourself. You don't have to type your email address into 50 different alerts.
Oh, that's a good point.
You just create one action group called Notify Ops Team, put your email and SMS in there, and then attach that one group to all your alerts. Someone leaves the team, you update it in one place.
But it's not just about sending emails, is it? The exam focuses on automation, self-healing systems.
Oh, absolutely. Email is passive. We
Yeah.
want active. An action group can trigger an Azure function to restart a service. It can call a logic app to scale up a VM set. It can even hook into ServiceNow and log a ticket automatically.
So the dream is server crashes at 3 a.m., monitor sees it, the alert fires, an action group runs a function to reboot the server, and you sleep right through it.
That's the dream. That's what we're all aiming for.
But here's the nightmare. It's a planned maintenance window. You know the servers are going to be rebooting. Do you really want your phone buzzing every 30 seconds?
That is called alert fatigue, and it is so real. It's dangerous. You get 100 false alarms, you're going to ignore the one real fire.
So what do? Do you just disable all the alerts?
No, because you'll forget to turn them back on. This is where you use alert processing rules. They used to be called action rules, which was a little confusing.
And what do?
They're like a layer on top of your alerts. You create a rule that says, between 10 p.m. and 2 a.m. on Saturday, for any alert in this resource group, suppress the notifications.
So the alert still gets created, the record is there.
Yes. For auditing, you can see it fired. But the action group, the part that sends the SMS and email, is blocked. It keeps your team sane and ensures that when an alert does come through, it's actually important.
Okay, let's shift gears. We've covered compute health, but so often the problem isn't the server, it's the plumbing, it's the network.
Ah, the old saying, it's always DNS.
Except when it's the firewall.
Except when it's the firewall, yes.
This brings us to Network Watcher. And first off, this isn't just on by default everywhere, is it?
No, and this is a classic exam gotcha. Network Watcher is a regional service. You have to enable a Network Watcher instance in every single region where you have a virtual network. If your VNet is in West US and your Watcher is only in East US, you can't troubleshoot the West US network at all.
You're flying blind again.
Totally blind.
Okay, so we've enabled it everywhere. Let's open the toolbox. I have a VM. I'm trying to RDP into it. It's timing out. I think a firewall rule is blocking me. What's my tool?
That's IP Flow Verify. It's a surgical tool. You give it the 5-tuple source IP, destination IP, port, protocol, and direction. It simulates that one packet.
And it just tells you allowed or denied.
More than that, it tells you which rule on which NSG denied it. Because you might have an NSG on the subnet, another on the NIC. This just cuts through all that noise and points to the exact problem. It's a lifesaver.
Okay, new scenario. My VM can't get to the internet. IP Flow Verify says it's allowed, but the traffic just vanishes.
Ah, then you need NextHop. This tool checks your routing table. It tells you where Azure is trying to send that packet next. Is it going to the internet gateway? Is it going to a virtual appliance, like a firewall?
Or is it going to a black hole?
Exactly. If the next hop type says none, that packet is being dropped on the floor. The source material had a great example where a custom route was pointing to a firewall appliance that had been deleted. NextHop showed the traffic was going nowhere.
So IP Flow, Verify for rules, NextHop for routes.
You got it.
And if I just want a simple check, can this web server talk to that database server? I don't care why, just yes or no.
Then you use Connection Troubleshoot. It's a broader tool. It actually tries to establish a TCP connection and tells you the latency and the path. It's like sending a scout ahead on the road.
Okay, fantastic. We've monitored, we've alerted, we've fixed the network, but sometimes disaster strikes anyway. Data gets deleted, ransomware. Now we need the insurance part of our theme, Azure Backup.
Right. We're shifting from fix it to save it. And this whole world starts with a vault. But, and this is important, there are now two types of vaults. They're not interchangeable.
We have the Recovery Services Vault and the newer Backup Vault. Why two? That seems confusing.
It's just the evolution of the platform.
Yeah.
The Recovery Services Vault, or RSV, is the classic one. For the exam, you need to know it handles virtual machines, SQL inside VMs, and Azure files.
Okay. And the Backup Vault.
That's the newer, more modern vault. It's for cloud-native stuff. It handles blob storage, standalone Azure disks, and PostgreSQL databases.
So if I try to back up a blob container to an old Recovery Services Vault?
It's not going to work. You won't even see the option in the portal. You have to match the workload to the correct vault.
Got it. Let's talk policy, frequency, retention.
Pretty straightforward. Frequency is how often, daily, hourly. Retention is how long you keep it. But there's a huge nuance here with trusted launch VMs.
These are the secure Gen 2 VMs?
Exactly. If you're using them, the sources are crystal clear. You must use an enhanced policy for backup. A standard policy will not work.
And the enhanced policy lets you do more frequent backups too, doesn't it?
Yeah, you can do multiple backups per day, like every 4 hours. Standard's usually just once a day. So if you have a tight recovery point objective, you need it enhanced anyway.
Okay, here's the scenario that keeps people up at night. A rogue admin gets in. They don't just delete the VM, they go into the vault and they delete the backups too. Is it all over?
It used to be, but not anymore. This is where soft delete saves you. By default, when you delete backup data in Azure, it's not actually gone. It's moved into a soft deleted state for 14 days.
So I've got 2 weeks to notice what happened, go in and hit on delete.
Exactly, and it's on by default and hard to turn off. It's a critical defense against ransomware that tries to wipe out your recovery options.
What about on-prem? I've got a dusty old Windows server in a closet with important files. Can I use Azure Backup for that?
You absolutely can with the Mars agent. That's Microsoft Azure Recovery Services. The notes had a funny mnemonic for it.
Mars, like the planet or the chocolate bar.
I'm also going with the chocolate bar.
Yeah.
It's a little agent you install on the Windows server, and it backs up files, folders, and system state directly to a Recovery Services vault. No big backup server needed. Straight to the cloud.
Nice. Okay, final segment. The big one. Backup saves the server, but what if the whole region goes down? A hurricane hits East US.
Now you're talking disaster recovery, or DR. And in Azure, the tool for this is Azure Site Recovery, or ASR.
Okay, break this down for me. How is this different from backup? They sound similar.
Backup is looking backward. Get me the file from last night. It takes time. Site recovery is about business continuity. It's about keeping the business running right now. It's focused on your RPO, how much data can you lose, and your RTO, how quickly can you be back online.
And it works by replicating the data.
Continuous replication. It copies the changes from your VM in your primary region to a secondary region in near real time. A file gets written in, say, UK South, and is copied to UK West almost instantly.
So when the disaster hits the primary region...
You hit the big red button, you initiate a failover, ASR spins up the replicated VMs in the secondary region, attaches the disks, and boots them up. You point your DNS over, and you're back in business.
That sounds great, but doing it for the first time during a real crisis sounds terrifying.
It is, which is why the single most important feature of ASR, and I guarantee this will be on the exam, is test failover.
The fire drill.
The fire drill, exactly. It lets you spin up your entire recovery environment in a completely isolated sandbox network. You can log in, check the apps, check the databases, make sure it all works.
Without touching production at all.
Without touching production. You can prove to your boss and your auditors that your DR plan actually works. Because if you haven't tested your DR plan, you don't have one. You just have a hope.
And hope is not a strategy.
Not in the cloud, no.
That's a powerful way to put it. So just to recap the whole thing, we have Azure Monitor with its metrics and logs to see what's happening. We use alerts and action groups to respond, and elect processing rules to stay sane.
Then we put on our detective hats with Network Watcher, using IP Flow Verify for rules and NextHub for routes.
And finally, our safety net. Azure Backup, remembering the 2 vault types and soft delete to save our data. And Azure Site Recovery to save the whole business when a region fails.
It's a complete ecosystem. It
Wow.
moves you from just firefighting to fire prevention.
Before we sign off, I have one last thought that came up in the source material. We talked so much about backing up data, but we also talked about how complex the infrastructure is, the NSGs, the policies, the routes.
Right. The configuration itself, the plumbing.
So if a region gets wiped out and you have your data, do you have a place to restore it to? If you built your whole network by hand, clicking in the portal, can you rebuild it perfectly in an hour during a crisis?
And that's the whole argument for infrastructure as code. Using templates like Bicep or Terraform, If your environment is just code, then your DR plan is just redeploying that code.
It's a really provocative question. Is your backup even useful if you don't have a house to put the furniture back into?
That's the ultimate deep dive question, isn't it? Data is useless without its context.
Something to think about. All right, that's our look at Domain 5. My advice: go log into a lab, set up an alert, break a network rule on purpose, and then try to find it with Network Watcher.
You got to break it to learn it. It's the only way.
Thanks for listening to the deep dive. We'll see you in the next one.